Awesome. Thanks, Bill, for that introduction, and thanks so much for having me here. As Bill said, I focus mostly on invasive plants, so you're going to see a kind of planty focus of this talk. And the other thing that I want to mention, so Bill also mentioned the Northeast RISC Network. The RISC Network is a collaboration between UMass Amherst, Cornell University, and the Northeast Climate Adaptation Science Center. And all of the things that I'm going to talk about today come from discussions with scientists and managers through the RISC Network. So those of you who've participated, thank you for your ideas. You may hear some of them coming back at you in this talk. If you need scientific evidence that invasive species harm ecosystems, this is from a meta-analysis from a couple of years ago, which shows pretty clearly a meta-analysis across almost 100 studies that as you increase invasive species abundance, so going low to high, you also see a correlation with a decline in native communities. So that could be native species abundance or native diversity. And on average, leading to about a 25% loss of native diversity as you go from low to high invader abundance. But I imagine that you're probably already convinced that invasive species harm ecosystems because you've seen, well, hopefully you haven't seen yet, a picture, something like this. So this is kudzu in the southeast, and this is a house, or was a house at some point. So we are already dealing with these huge challenges associated with invasive species. And now we've got people like me, people at risk, people from the state coming in and saying, now you need to think about climate change, right? So those are two huge challenges already. And through this talk, I hope to break some of those down a little bit of how we can put those two things together. And hopefully by the time we get to the end, you can see a little bit of silver lining on this, that we do already have the tools to be proactive and to get some wins against invasive species in the context of climate change. One piece to start out with is some good news. So these are the results from another meta-analysis. So that's essentially a scientific reanalysis of lots of different, in this case, experimental studies that looked at the effect on native species or native ecosystems of some form of global environmental change, so that's GEC here, invasive species alone, and the combined effect of invasive species and global environmental changes. And the global environmental changes represented here are climate warming, drought, and nitrogen deposition. So what you see here is that alone, those global environmental changes have a negative, but not significantly negative effect on ecosystems. Invasive species have a clearly significant negative effect on ecosystems, but the combined effect of invasive species and global environmental change is no worse than invasives alone. So this says to me that if we can address the effect of invasive species, that's going to go a long way towards mitigating the ecological impact of these two things combined. The other silver lining in terms of thinking about what's coming with climate change is that right now, most of the species that we're managing are already, the horse has escaped the barn at this point, right? Those species that we're managing are widespread. We are managing species in areas where they haven't yet gotten to. We're focused on, preserving natural resources that we really care about. But when we add climate change to this mix, that challenge, that creates a new challenge, but it also creates an opportunity because we're here at the prevention stage when we think about climate change. Those species haven't, many of those species haven't even arrived here yet. Some of those species might be at very low populations and be treatable today, unlike many of the ones that are widespread. So I've got kind of a lengthy list of things that I want to talk about in terms of becoming more climate smart in our invasive species policy and management. This all comes from a paper that was published earlier this year in the journal Bioscience. So, and at the end of this talk, I can drop a link that you can download that paper. So if you want the Cliff Notes, or maybe not the Cliff Notes, the extended notes on this topic, that's the place to look for it. So going down that list that I flashed through a minute ago, first piece in terms of things that we can do to be more climate smart in invasive species management, first is to learn about invasive species and climate change. So knowledge is power. In this case, the more you know, the more you can think about how to integrate climate change, and the more you can teach as well. At Northeast RISCC, we do a lot of synthesis of research and create resources associated with that synthesis. So if you're looking for some of that information, we've got lots of webinars posted on our website about various research topics on invasive species and climate change. We also pretty regularly put out these what we call management challenges. So in this case, taking action is about managing invasive species in the context of climate change. That's on our website, came out a couple of years ago. And we also have one that's sort of a primer on the ways that invasive species and climate change interact. So just to go through these 6 things really quickly, ways that invasive species and climate change interact. One is that as we get more extreme events, strongly predicted with climate change, more intense hurricanes, more intense rainfalls, as well as longer and more extended droughts, those harm native ecosystems and create opportunities for invasion. I'm going to go clockwise around. Phenology gets extended, so as invasive, especially forest pests, as those start emerging earlier and staying longer, that gives them an extended growing season or multiple life cycles, which can harm plants and forests. We're seeing invasive species shifting their ranges, so species that are invasive in the southeast are headed towards the northeast. New York is particularly actually susceptible to new pathways of introduction as the historic Northwest Passage is now opening up because of less sea ice in the Arctic. So you're able to get, you're lucky enough to be the recipient of potential invasives coming directly from temperate East Asia to temperate North America. We're seeing that invasive plants in particular are becoming more competitive with, especially with higher atmospheric CO2, which acts as a fertilizer, and they are good with fertilizer. And we're also seeing for plants specifically that herbicides are less effective because plants are putting more of their biomass below ground as with that atmospheric CO2 fertilizer. So now you know everything there is to know about invasive species and climate change. Please use our resources, check out other people's resources, get to know what's going on, because the more you're thinking about it, the more you're also thinking about solutions. Second main piece here is sharing information across borders. So this is a map of actually almost 900 invasive plants in the US, and their projected changes by about 2050 with climate change. And all the red areas on here are hotspots of new invasive plants. So you can see the whole Northeast, definitely something that we're worried about in the RISCC network. New York could have upwards of 100 new invasive plants that could establish in the state by 2050. The good news here is that our southern neighbors know about those species, and they also could tell us what's coming. So we did a survey actually back in 2018 that asked information about like what are the species that you're currently managing and what are the species that you're worried about that are emerging in your state. So let's just look at the one on the right here. This is for stiltgrass, so microstegium. The blue dots on here, so that I guess the orange behind here is the EDMAP's county distribution of where stiltgrass is present. The blue on here are manager locations where people reported that they're actively managing stiltgrass. They're dealing with it today in 2018. And the red dots on here are all manager locations where they reported that stiltgrass is an emerging species that they're really concerned about. So the more you guys in New York can start talking to folks in New Jersey and Pennsylvania and further down into the mid-Atlantic, the more you're going to have ways to exchange the information that you need for those species that are on their way. So focusing on ways to promote that information exchange feels really important in the context of climate change. This type of call that you have is amazing, that you are exchanging information across the state. So thinking about trying to add some folks from some neighboring states further south and in warmer climates. This is just an example of a webinar that we did several years ago, focused specifically on bringing some experts from the Southeast, scientists and managers, to tell us, what are the ways that we best deal with microstegium. Another really important piece is developing consistent and proactive invasive plant regulations. So why are we able to regulate invasive plants? I'm sure you all know this, but the reason is because most invasive plants are introduced as ornamentals. And so because they are a deliberate introduction, we actually have a mechanism for evaluating risk assessment of those species and potentially regulating the most risky ones. So we have a regulatory tool. New York has a very nicely developed risk assessment tool. The problem is that across the US, if you look at what invasive species are available, we find that 61% of species that are identified as invasive somewhere in the US are still offered for sale somewhere in the US. So it doesn't mean that we're selling the species, that if a species is prohibited for sale in New York, that it's commonly sold in New York, but it may very commonly be sold in New Jersey and Pennsylvania, which have very many fewer species that are regulated than New York. And since those are your direct neighbors, Connecticut, Vermont, Massachusetts, I shouldn't just blame Pennsylvania and New Jersey. Your direct neighbors are also contributing to your invasive species problem. So consistency is a big problem. In terms of climate change, the other thing that we're missing from a regulatory perspective is that we rarely regulate the species that are coming next. So New York actually has a non-zero number in this case, that 5 of the species, this is from 2019 was the last download of these data from this paper. So as of 2019, New York had regulated 5 invasive plants that were not yet present in the state. But if we've got 100 new species coming into New York by 2050, we can do a lot better than 5 species, and essentially stop those species from arriving and spreading way before they become a problem. And they are already becoming a problem. So nursery sales are already likely to be facilitating the range shifting of invasive plants. This is just an example for Nandina domestica, so sacred bamboo, identified as invasive all across the Southeast, not really regulated at all in the Southeast. It's a very popular nursery plant. Not particularly widespread in the Northeast because it's a little bit more warm temperature tolerant, and not particularly sold. So these triangles are nurseries that are selling sacred bamboo. But you can see that there's at least one nursery, and this was not a comprehensive assessment of all nurseries. It was just sort of Googling for sacred bamboo to see who was selling it. So probably more than one nursery in New York that's already selling sacred bamboo. Those nurseries are essentially seeding future invasions. So if we can be more proactive about our risk assessments and our policies, we get a win-win, or at least one win, many wins, depending on the number of species. Another really good piece of news here is that New York has already done risk assessments for a lot of these range shifting. In fact, almost all of the range shifting species in that initial modeling exercise that Jenica Allen led. And so we've got risk assessments. We know which ones are high risk. And we just need to move those ones from risk assessment into policy action and regulation. So the more that you can do to make that, to push on that effort and say, keep pushing and needing more regulation of these high risk species, the better off we're going to be. Just to show you what's in this graph. So this is, as of 2019, New York had 69 invasive plants regulated. And we're just showing this across a graph of how widespread those species are. And widespread here is based on the number of counties that that species is present in. So we've regulated some species that are present in all counties. We've regulated some species that are absent from all counties, right? Those 5 proactive species. But, you know, for the most part, we're regulating species that are pretty common not in Massachusetts, in New York. So from 25 to 75%, that's most of the species that we're regulating. Over here are all of the species that have been evaluated. And there's a big chunk here in high risk. I just want to draw your attention to 100 species that have been assessed as high risk for the state of New York. And the majority of those species are absent from the state of New York. So there's lots of species that have already gone through the risk assessment process and just need to move from here to here in order to be much more proactive and, you know, prevent those introductions and distributions before the species even have the chance to arrive. Part 4 here. I'm doing the classic professor thing of trying to cram a 40-minute talk into 25 minutes. So that's why I'm like kind of flying through this a little bit. Horizon scanning is another really important piece of climate smart invasive species policy and management. Horizon scanning means actively looking ahead for invasive species that are coming next. And so that includes range shifting species, but it also includes potential future introductions. So, you know, all of the accidentally introduced species, you know, if we had horizon scans for spotted lanternfly and we knew that that was a species of risk 10 years ago, what might we have done differently to prevent that? A challenge here is that most nursery plants, so again, focused on plants here, are already pre-adapted to climate change. That's because nurseries generally give non-native introduced plants a head start. They tend to introduce them in warmer climates than their native range. So this is an example for Europe. So this species of Saponaria, which I've been fighting from my front yard for the last 2 years, is native to Southern Europe. So all of these red areas is where that species is native. And the green dots, which you can, those of you who are not red-green colorblind can see the difference between the green and red here, but they extend all throughout its native range, but they also go up into these much cooler climates, you know, like way up into Northern Europe. So Saponaria in Europe, so this is a neo-native expanding, but it's also been introduced over to North America into nice warmer climates, and that gives it this big advantage. There are tools, fortunately, for horizon scanning. So CABI, if you're not familiar with the CABI, you know, invasive species compendia and a lot of the resources they've pulled together, they've done a great job of getting global information about invasive species into a single place and a single resource. That includes a horizon scanning tool. The state of Florida a couple of years ago used that horizon scanning tool, and then a bunch of additional steps associated with you know, expert knowledge to narrow down what started out as about 2,000 species down to about 100 species. And then did some, you know, further risk assessment to identify ones that they thought were highest risk for Florida. Florida, of course, doesn't have neighbors to the south to look to for range shifting species. So very much they're considering, you know, globally, what are the species that we need to be looking for. Every state should be doing this so that we can identify, you know, not just prevent the intentionally introduced species that are high risk, but also be on the lookout for, you know, high risk accidental introductions so that we can, you know, get on them, be monitoring for them, and respond rapidly. Climate smart restoration is another really key piece in terms of thinking about climate smart invasive species management. I'm sure you all do lots of invasive species treatments, and I'm sure you've also been involved in lots of restoration following those treatments. A challenge for sort of traditional restoration is that climate change is happening really fast. So I'm from Massachusetts. These are the projections of what Massachusetts looked like when I was a kid. Massachusetts now has migrated to northern New Jersey in terms of climate. By the end of this century, even in the best case scenario, which we're not really in anymore, Massachusetts would be down in the mid-Atlantic, and in the worst case scenario, which may be more realistic, we could be all the way down in the southeast. And so 800 miles is a really long distance to expect plants to be able to move on their own. And it also means that, the plants that are native to Massachusetts are not going to be surviving climates for South Carolina. So that means that whenever we're doing or thinking about invasive plant restoration, we have to now begin experimenting with warm adapted genotypes and warm adapted species. So that includes species that are not currently or haven't sort of historically been at that site. And this guidance from the science side has been around for a really long time. So this is, or really, I don't know if 15 years is really long, but a long time from a climate change perspective since we've been doing a lot of this work. So this is from a paper in Forestry by Connie Millar in 2007. And some of the main recommendations are in forests, the need to expand genetic diversity guidelines, which means taking genetic pools from warmer climates from further south, not just sourcing locally for our seeds for restoration. And another big guideline is to establish neonative forests, so that we need to do assisted migration, the movement of species northward in response to climate change. Some good news is that there are not a huge number of studies on provenance of seeds for restoration. This is actually one that was done in Europe. But what they found in this study was that it didn't really matter whether you took seeds from local versus from non-local, so more warm adapted seed mixes. They pretty much performed similarly in terms of germination and growth rate, and whatever else restoration ecologists look for in terms of metrics of success for seeding afterwards. So basically that means that if you take seeds from, Pennsylvania, Maryland, Virginia, further south, that for the most part, the science suggests that they're not going to, totally crap out on you, kind of thing, and lead to failure for a restoration project. A lot of folks are really concerned about assisted migration, assisted gene flow associated with, with climate smart restoration. It makes sense. It makes sense, especially for us who work with invasive species, to worry about harm that we may cause by moving species around. The problem is that we fail oftentimes to balance that against the harm of doing nothing. Doing nothing is causing a huge amount of harm to ecosystems, because a tree cannot move 800 miles in the next 50 to 100 years, right? It's not something that a tree can do without our help. So I very strongly think that moving species assisted gene flow and assisted migration experiments are something that we need to be doing today. One of the things that we can do to support that is to continue working on building seed supply and seed chains. That's a major barrier right now. So supporting collection, banking, production. There's a fantastic network, if you haven't heard of it, that has just started up in the last year or two, called the Ecological Health Network, that's working on a lot of these seed supply challenges. All right, and then this is my last topic, which is people as part of the solution. And again, I'm going to focus on plants here and planting. So what I want you guys to take away from this piece is that what we need is ecological landscaping as a social norm. And what I mean by that is, when you walk down the street in your neighborhood, native meadows in the front of a house should be equally positive and looked at as some manicured lawn, right? The challenge to this is when you look at, so this is actually a study from Kentucky. There haven't been a whole lot of studies on this, and these are various different sources of plants that were available at nurseries across Kentucky. But the main take home is that native plants on average made up about 30% of stock available to homeowners, and introduced plants from various different sources made up about 70% of stock available to homeowners. And, you know, so the nursery trade folks will be the first to tell you that they're just responding to demand. So what we need to do is to change, you know, keep working on changing this demand, right? So the more we keep talking about pollinator gardens, the more we keep talking about supporting native flora and fauna, the more we keep talking about not being that guy who introduces the next bad invasive species, you know, like the better off we are in terms of getting that message out to homeowners. Lawns are ecological wastelands. You know, this should not be our social norm in the U.S. because it misses in terms of any kind of environmental stewardship. It has no capability of adapting to climate change, and it also has the possibility, depending on what else they're planting here, of introducing non-native invasive species. So better than that is to think about native plant landscaping. So starting to say like, okay, a native meadow is, you know, is part of what I would expect a lawn yard to look like. Even better than that is thinking next steps. So not just planting, you know, native meadow species that are already native to New York, but also thinking about adding in those neo-native species, right? If the status quo right now is planting introduced and invasive plants, so what we should be doing is instead encouraging our gardeners to plant these warm adapted natives. Let our yards be part of that solution to helping plants move across landscapes with climate change. And so just examples of ecologically friendly policies. To the extent that you have power or influence over the landscaping at your own institutions, enabling those institutions to lead by example with climate smart landscaping and incentivizing ecological landscaping. You know, like my dream is that if there's subsidies for solar panels, shouldn't there be subsidies for supporting native flora and fauna, you know, to buy homeowners seeds? All right, I managed to get through in almost 25 minutes. So if you're interested in talking more about invasive species and climate change, and you haven't joined the RISC network, please do. We have a listserv, so you can hear more about what we're doing, sign up for some of those activities. And I'll just leave the key topics up there, I guess, if we have maybe a minute for questions.